In this video, we're going to learn how to divide mixed numbers. So let's read the directions. Rewrite any mixed numbers as improper fractions, then perform the division by multiplying the first fraction by the reciprocal of the second fraction. We'll simplify our result and rewrite as a mixed number when possible. Okay, so first, we're given a description of how to do this. We're told that we should rewrite mixed numbers as improper fractions, and mostly this is a good way to go, and here's why. So looking at this first problem, remember when you say 2 and 1/2, that's how you read this number. That means 2 plus 1/2. And then we have divided by 1/2. Okay, so we know we're supposed to perform the parentheses first. Okay, if we just rewrite this as a mixed number, there's really that hidden addition in there. Okay, so this is why we want to write this as an improper fraction first, because as an improper fraction, there's no hidden addition like there is in mixed numbers. Okay, you should also look at these. It's nice to go right to the algorithm and perform the process, and you need to know how to do that well. But you can also think about, well, 2.5 divided by 1/2 is asking us how many 1/2s are in 2.5. Well, there's 1 1/2 and 1/2, and for each whole has 2 1/2s, so 2 wholes would have 4 1/2s. So there's going to be a total of 5 1/2s in 2.5. Okay, so before you even do the problem, you can start to think through and reason through these problems. Okay, so now let's use this process they talked about. So we'll start by, we're going to write the equivalent division problem, but we're going to write this as a mixed improper fraction. So 2 times 2 is 4, plus 1 is 5. So 5/2 divided by 1/2. Notice I didn't reciprocate this. I didn't change it into multiplication yet. I just wanted to rewrite the equivalent problem with improper fractions just to show my work. Now in the next step, I'm going to take 5/2. Once you change to multiplication, you must reciprocate the second fraction. Also, if you reciprocate the second fraction, that's when you need to change it to multiplication. So this division statement is equivalent to this multiplication step, and you should do those simultaneously or in the same step. Okay. Now we can multiply across 5 times 2 over 2 times 1. 2 divided by 2 is 1, so these cancel to 1, and we get a result of 5, which makes sense. That's what we thought of in the beginning of the problem. Let's look at the next one. We have 3 4/5 divided by 2 3/8. So looking at this to start, I'm thinking how many 2 3/8 are in 3 4/5? And honestly, I don't know, but I can tell you there's at least one, since 3 4/5 is bigger than 2 3/8. And double 2 3/8 would be more than 4, so my result is going to be between 1 and 2. Okay, it's nice to have an idea of where your answer is going to be. So if you get 74 as an answer, you know you've made an error. So let's start by writing these as improper fractions. 15 plus 4 is 19/5 divided by 8 times 2 is 16 plus 3 is 19. So we have 19/8. Okay. Now I'm going to reciprocate the second fraction and change it to multiplication. 19/5 times 8/19. Okay. Now we've been canceling after we multiply without actually doing the multiplication, but you could start to cancel them out here if you prefer, but I'm going to keep writing them as one fraction of a product over another. We have a common factor of 19 in the numerator and denominator, which cancels to 1. And then we are left with 8 in the numerator and 5 in the denominator. As a mixed number, 5 goes into 8 once, with 3 left over and a denominator of 5. So there are 1 3/5 copies of 2 3/8 and 3 4/5. And that seems to make sense. That's between 1 and 2, so that seems reasonable. Let's look at the last one. So 1 2/5 divided by 3 3/5. So how many copies of 3 3/5 are in 1 2/5? Well, I know there's less than 1 because 3 3/5 is bigger than 1 2/5. I even look at this a little bit and I look at the whole numbers and I think it'll be about 1/3. So the fractions change it a little bit. That's not our exact answer, but again, trying to just get a feel for what the answer is. So it's going to be between 0 and 1, maybe about 1/3 or 1/2 is what I'm guessing. So let's find the exact solution. Change it to an improper fraction. 5 times 1 is 5 plus 2 is 7/5. Divided by 5 times 3 is 15 plus 3 is 18. Okay. Notice this one we could use the dividing across since the denominators are the same, but we haven't done one where we reciprocated, so let's do that. Okay, so I change to multiplication and reciprocate, and notice why this works here. The 5s will definitely cancel each other out, and we're left with 7 divided by 18. So that corresponds to our previous result. So we have 7 times 5 over 5 times 18. The 5s both cancel to 1, and we have a result of 7/18. Okay, since this result is less than 1, which is what we expected, we don't need to write it as a mixed number. And I just want to look at something. So we said it'd be about 1/3. 1/3 as a decimal is 0.333. 7/18 is 0.388 forever. So those results are consistent. Again, I'm not looking for the exact answer when I approximate it first, but it gives me a ballpark of our answer.